Scooping one cup of seawater and coming up empty does not mean there are no fish in the ocean. But if you drain the entire Pacific and still find nothing, not a single fish, that is not just surprising, that is terrifying. And that is exactly what humanity has done to the universe. We have scanned 400 billion stars in the Milky Way. We have monitored 2 trillion galaxies. We have been searching for 70 years. And by the math, there should be roughly 1 billion civilizations out there right now. The result? Nothing but static. It is like walking into a packed stadium with 80,000 people, every light blazing, every seat filled. But there is no breathing, no footsteps, no heartbeat anywhere. You would think one of 3 things. Either you have gone deaf, or you have lost your mind, or every single person in that stadium is already dead. Those are the 3 answers the universe is giving us, and each one is more disturbing than the last. On a regular afternoon in 1950, Nobel Prize-winning physicist Enrico Fermi was having lunch with colleagues at Los Alamos National Laboratory. He put down his fork and asked a question that stopped the table cold. Where is everybody? Nobody had an answer. That offhand remark became the most haunting question in science, what we now call the Fermi paradox. And 75 years later, we still cannot solve it. Fermi's reasoning was straightforward. The Milky Way has 400 billion stars. Even by conservative estimates, at least 10 billion of those stars have Earth-like planets orbiting them. The universe is 13.8 billion years old. Earth is only 4.6 billion. If life tends to develop wherever conditions allow, then civilizations that got a head start on us by 1 billion or 2 years should have had more than enough time to spread across the entire galaxy. Even if their ships maxed out at just 1% of the speed of light, they could blanket the Milky Way in 10 million years. In cosmic terms, 10 million years is nothing. It is a rounding error. And yet we see no signs of anyone. No megastructures, no transmissions, no footprints of any kind. Something does not add up, and whatever it is, we have not figured it out yet. In 1961, astronomer Frank Drake decided to put some math behind the mystery. He developed what became known as the Drake equation, a formula that breaks the question down into 7 factors. How many new stars form each year? How many of those have planets? How many of those planets could support life? What fraction actually develop life? What fraction of that life evolves intelligence? What fraction develops the ability to communicate? And finally, how long a civilization typically lasts? When scientists started plugging in their best estimates, the results were staggering. The Milky Way alone could contain anywhere from 10 to 10,000 active civilizations right now. Even the most cautious guess lands at 10. So why have we found 0? It is not like we have not been looking. In 1960, Drake kicked off Project Ozma, the first organized scientific search for extraterrestrial intelligence in human history. He aimed a radio telescope at 2 nearby sun-like stars and listened for months. He heard nothing. But humanity kept at it. 65 years later, our instruments are vastly more powerful and our search is far wider. China's FAST telescope, with its 500-meter dish, is the largest single-dish radio telescope on the planet. Its receiving surface covers the equivalent of 30 football fields and can process more data per second than an entire library holds. Stephen Hawking once remarked that if any civilization on Earth is going to be the one to make first contact, it will probably be China. Beyond just listening, we have also been sending. In 1977, NASA launched Voyager 1 and Voyager 2. Each spacecraft carried a gold-plated copper record loaded with the sounds of Earth: ocean waves, wind, thunder, birdsong, whale song, and greetings spoken in 55 human languages. The cover of the record included a diagram using pulsar positions to pinpoint Earth's location in the galaxy. It was essentially a cosmic message in a bottle. 48 years later, Voyager 1 has crossed beyond the heliosphere and is now the farthest human-made object ever launched into space. It sits roughly 24 billion kilometers away, cruising at about 17 kilometers per second. And even at that speed, it would still take 70,000 years to reach the nearest star. If someone out there picks up that record tens of thousands of years from now, what they will hear are the final words of a civilization that may no longer exist. In 1974, we did something even more audacious. The Arecibo radio telescope beamed a message directly at the M13 star cluster. The transmission contained 1,679 binary digits that, when decoded, formed a picture. The structure of human DNA, the layout of our solar system, the average height and total population of humanity, and the silhouette of a human figure. We essentially mailed our home address to the cosmos at the speed of light. That message is still traveling toward its target, 25,000 light years away. Even if someone receives it and writes back immediately, their reply will not reach Earth for another 50,000 years. The civilization that sent the message will almost certainly be gone by then. But the strangest moment in this whole story came on the evening of August 15, 1977. The Big Ear radio telescope at Ohio State University picked up something unusual, a signal lasting exactly 72 seconds. Its intensity was 30 times stronger than background noise. Its frequency was precisely 1,420 megahertz, the natural resonant frequency of hydrogen, the most abundant element in the universe. Scientists consider this the cosmic watering hole, the frequency that any spacefaring civilization would logically choose for interstellar communication. The astronomer on duty that night, Jerry Eman, stared at the printout, circled the data by hand, and scrawled one word in the margin: "Wow." The signal has been known as the WOW signal ever since. Where did it come from? Unknown. What caused it? Unknown. Why has it never repeated? Also unknown. For 48 years, researchers have pointed telescope after telescope at that patch of sky and found nothing. Some believe it was a message from an alien civilization. Others say it was interference from a piece of equipment here on Earth. A few researchers have proposed it came from the hydrogen cloud trailing a comet. The truth is buried somewhere inside those 72 seconds, and we may never dig it out. So maybe civilizations are out there, but they are choosing not to respond. One of the most chilling explanations for why is something called the dark forest theory. The idea goes like this: the universe is a dark forest. Every civilization in it is an armed hunter moving through the trees. You have no idea how many other hunters are out there. You do not know whether they are allies or threats. The only thing you know for certain is that if you make noise and reveal your position, you might not survive it. So every civilization that has managed to stay alive has learned the same hard lesson. Go quiet. No signals, no broadcasts, no traces. Exist like a ghost. The civilizations that were enthusiastic about announcing themselves to the universe may have already been silenced. Meanwhile, humanity has been broadcasting our presence for 120 years and counting. There is another possibility that is somehow even more unsettling. Maybe they are not hiding from us. Maybe they just do not think we are worth acknowledging. This is called the zoo hypothesis. Think about it this way. Would you walk up to an ant colony and introduce yourself? Would you try to open diplomatic relations with a hill of ants? Of course not. The gap between you is too enormous. Communication would be pointless. The ants simply do not register on your level. In 1964, Soviet astronomer Nikolai Kardashev proposed a way of ranking civilizations by how much energy they can harness. A Type 1 civilization controls the full energy output of its entire planet, roughly 10 to the 16th power watts. A Type 2 civilization controls the full energy output of its star, around 10 to the 26th power watts. A Type 3 civilization controls the energy of an entire galaxy, somewhere around 10 to the 36th power watts. Where does humanity fall on this scale? We are at approximately 0.73. We have not even cleared Type 1. We have not fully figured out how to use the energy resources of our own planet, and we are already anxious about running out of oil. A Type 2 civilization could build a Dyson sphere, a massive structure wrapped around an entire star to capture every photon it emits. A Type 3 civilization could travel between galaxies, run on black holes, and communicate using gravitational waves. To an entity like that, our radio signals are about as meaningful as the chemical trails ants leave on a sidewalk. They could detect them, but why would they bother? The nuclear weapons we consider our most fearsome technology would look to them like a box of matches. Our fastest spacecraft might not outpace their version of a robotic vacuum cleaner. This is precisely why finding extraterrestrial life might not be the triumphant moment we imagine it to be. If we discover microbial life, that is significant but manageable. It would confirm that life is not some miraculous accident unique to Earth, but something the universe produces regularly. We would need to rewrite the textbooks and rethink some deeply held beliefs, but day-to-day life would carry on.
The real question is what happens if we find an intelligent civilization? The optimists imagine a grand interstellar partnership, shared knowledge, joint exploration of the cosmos. But history keeps interrupting that fantasy.
In 1492, Columbus reached the Americas. He did not bring friendship. He brought smallpox, guns, and forced labor. Within a century, the indigenous population of the Americas had fallen by 90%. An entire world was nearly erased. And crucially, Europeans and Native Americans were both human. They shared biology, emotions, and basic needs. An alien civilization would share none of that. They might not be carbon-based. They might have no use for water or oxygen. They could be silicon-based, or exist as pure energy, or take forms we lack the framework to even imagine. Their entire way of perceiving and processing reality might be on a dimension completely foreign to us. From their perspective, wiping out humanity might not even qualify as a moral decision. It might just be something that happens, the way you might step on an ant crossing a sidewalk. No malice, no guilt. You probably did not even notice. So given all of that, why do we keep looking? Why do we keep broadcasting, probing, and reaching? The answer is that we cannot help it. It is not a rational choice. It is an instinct baked into us at the deepest level. The moment the first human looked up at the night sky and felt that pull, it became part of who we are. We are the only species we know of that stops to wonder why it exists. We are the only species that shouts questions into the void. If we are truly alone in the universe, then we are not just one civilization among many. We are the universe's only set of eyes, its only awareness, its only chance to know itself. 13.8 billion years of cosmic history, from the Big Bang to the first stars igniting to clouds of gas collapsing into worlds, all of it leading up to this. A species that can look back at all of it and ask what it means. That is an almost unbearable kind of loneliness, and an almost unbearable kind of purpose. But if there are others out there, then we are just one tree in a forest that stretches beyond anything we can see. Ordinary, expendable, easy to overlook, but not alone. Either answer will reshape human civilization at its foundations. Right now, Voyager 1 is cutting through the dark 24 billion kilometers from home. On the golden record strapped to its side, there is a message recorded in Mandarin Chinese. It says, "Greetings to you all. We miss you very much. Please come visit us if you can." Maybe someone will hear that message tens of thousands of years from now. Maybe no one ever will. But we sent it anyway. And that matters. It means that in this vast and silent universe, at least one civilization was here. At least one civilization thought about it. At least one civilization looked up and waved. And that, all by itself, is enough of a reason. When you stare into the abyss stares back. When you look up at the stars, maybe, just maybe, the stars are looking back at you too.